Greetings, I'm Jason Sage of Jagus LLC, and this is Pascal 102. And we're going to cover some topics about FreePascal to continue on where we left off with the Pascal 101 video. If you haven't seen that, I encourage you to do so. It involves downloading and installing FreePascal and getting a little program started that just does more or less what we call a Hello World program. Started that iterates through a loop, prints a couple things on the screen, and we're going to take a quick review look at the final program of that, and then we're going to move forward. Alright, so let's start by showing my desktop and looking at our folder here, which we have a temp directory which has my temp Pascal. I think this is the one that we made in that video. I believe it is. If not, we're going to write one real fast. Let's see. Well, there's nothing here, so we're going to write it real fast. Program temp, and we have variable, we had an integer, and we had a string. I like to use ANSI-string. It's a dynamically allocated string, so you can keep appending onto it forever. However, its performance is noted to be slower than using the other Pascal string variety, which looks like this, which automatically defines it out to 255 characters, I believe. And you can also set its exact length by using square brackets and actually setting the exact length of the string you want to work with. So those are things to be aware of. You can use both. So going back to what we did on the beginning loop, we basically had a loop that used the integer using for I equals, let's say, 1 to 10, do. And then we have begin. Remember, you want to pretty much have semicolons after almost everything. At the end of a do, you don't, because it's the start of a construct. And like I mentioned in the previous video, you could do something like this on one line, print right line hello, and this would qualify and would write 10 lines of the word hello. But what we're going to do is, generally when you're working with a loop, you're dealing with a block of code as opposed to a single line. So we're going to do a begin and an end. Notice I follow the end, not the begin, with a semicolon. So end has a semicolon at it. And right here we're going to just right line. We're going to right line our number I. I'm going to put a space in there, and I'm just doing the comma thing just to make it separate from what I'm doing with the variables. And I'm going to use the variable name SA, which we declared above. So above our loop, I'm going to say SA equals hello world. Now note I already have FreePascal installed. I'm using version 2.4.2, I think. And now we're going to do end here as well, but because it's the end of our program, we actually use a period to denote that. The same is true with a unit. And we're going to go over units in a moment. But units basically all have a spot where you can initialize them. So just the fact that you're using a unit, just by using it, you can actually have code that is fired at the beginning of the unit's use. Before you do anything with it, it just gets fired right away. So you can have initialization code there, for example, as if it was a class even. Good things for it are resetting variables to nothing, maybe, whatever basic tasks you want to have for a given unit. But again, we're going to touch on units in a bit. So let's just take a look at our little starter program here. I'm going to make sure I save it, and I'm going to exit it. I'm using Jagus Edit, by the way. It's an editor written by Jagus LLC. And it actually has the ability to compile and run FreePascal programs right from within right from within. But I want to show this without those tools first. And I'm going to start by making a shortcut, a new Windows shortcut, and I'm going to type in CMD for command line. The problem is when you first create one of these things, which I just did, which is very fast. In fact, I'll do that one more time to bring it into slow-mo for you. Let me just delete this, delete. There we go, delete. It's gone. I'm going to say right-click. Where is it? New shortcut. I type in CMD, and I just press enter because it's the default button next on the bottom right there next to cancel. Has already got like a little bit of a blue tinge. That's the default key. Hit enter. It says type the name for this shortcut. I just let it be command.exe. I know what it is. I hit enter. There we have it. Now, but here's the next thing you got to do. See, if I double click on it now, the default directory when you make one of these shortcuts for a command, for the command CMD program, is Windows System 32 or something like that. So if I double click this, I end up in the Windows System 32 directory. That's not where my temp program is. That's not where I want to be. I want it to be right here. So I right click on it, I go to properties, and right here it says start in. It's in the middle of the dialog. Start in. I want to change that to blank. So if I copy this or if I copy this somewhere else, it'll always open the directory it's currently in, not open up to Windows System 32. So now that I have this, I'm going to double click it, And I'm going to try to make the font a little bit bigger here so we can I can go to properties on the bottom of that menu that I pulled down from that icon in the upper left and make the letters and stuff bigger so you can see what's going on. We could probably even do better than that, I think. Let's see, can we go bigger? 1216? I like 1216, that looks better. Alright, I think that might be easier to read. Okay, so FPC is FreePascal. If it's in your path, you should be able to get to it from anywhere on your machine. We covered that in Pascal 101 on how to do that. When you install FreePascal, it does add it to the path in the Windows installation. But I also covered in the Pascal 101 video so that you can actually go in there and how to change the path if you're not aware of that, or how to verify that FreePascal is in fact in your path, and how to change it if you need to. Alright, so now we're done here. I'm going to hit Control-C. I just wanted to show you that it does, in fact, it's running, or I have it available to me to run. We're going to compile our temp program, so I just say FPC temp. I don't need to put in the file extension. And I do that, and I'm going to run my little temp program just by typing temp. We have a little exe. Let me do dir first so you can see. We have right here our temp. It's not going to let me mark because it's just like that. So right here, I have temp exe, and it's 32K, which is pretty small. And it's not too shabby. So let's see, there's even other things you can do to compile it to make it even tighter than that. But anyway, now that we have that set up, I'm going to type in temp, and it says hello world, and if you'll notice, it has the number on the left hand side, the 1 2 3 4 5 6 7 8 9 10. Alright, if we go back and look at that code, we're going to see why that is real quick, and then we're going to move on to some other stuff. Okay, right here we have the for loop that counts 1 to 10, and we're doing a write line. The I is the variable that's doing the counting. That's what I printed first. That's why we got the number on the left-hand column. Then I printed a space. Notice I used a comma to separate the different variables or types. In this case, it's a hard-coded space, but so what? That's fine. Then I do a comma, and then I have the SA variable, which I declared up here, and that gave me the hello world. Now, one more thing I want to do real quick is we have this ANSI string up top, and I said how that allows you to make strings as long as you want and everything, and it's dynamic, it's handled in memory, memory's allocated, pointers are used, all behind the scenes. You don't have to worry about it, which is very convenient. However, like I said, it's slower, so you need to know about how the string works. So let's just show you how interchangeable that is. Alright, it says I have string 10, but I want to make sure that I have enough room. I'm not feel like counting letters, so we're going to do this. I just got rid of the ANSI string. We only have the variable called s. S equals hello world, and we're going to go over here and change the variable to s. And we're going to close this program. We're going to go back to our command prompt. We're going to compile temp again. It compiled, no problem. And then we go temp, and there it is, does the same exact thing. So string and ANSI string are interchangeable. ANSI string has a slower bit of performance, but it has, I think, a lot more power. You can load up a string like megabytes, and you can do half a gig or whatever. There's really no limit. Of course, if you get the larger you get, it's going to impact. Obviously, it's going to impact the performance of your application. So you want to use these things wisely, but it's nice to not have to worry about the length of a string. Like if someone has a note field, for example, where they type in a paragraph, paragraphs, pages of text, you can put them all in an ANSI string, and I think that's a wonderful thing. So, okay, let's take a look at this a little further. First of all, let's go look at FreePascal itself. When you install it, this is my FreePascal directory. I installed it to drive C, P, FPC. A lot of times people just install it with the default, which would be C, FPC. These letters aren't driving you crazy me saying them, but in here you have the version of the FreePascal that you have installed. Inside of that directory, there's the bin folder, which one folder more down is the actual architecture compiled version of the FreePascal that you have installed or that is available. In some situations, when you get pretty advanced with FreePascal, you might actually have multiple directories here for different architectures, especially if you're doing something which is pretty complex, cross-compiling, where you actually have the source code to FreePascal and you are compiling it for Linux, compiling it for Apple, compiling it for Unix, compiling it for Windows, compiling it for ARM architecture. It's very portable. It works on a lot of different CPUs and operating systems and such. So, but we're just dealing with Windows, and that's good enough. The language is consistent regardless of all the other stuff. So, that's the bin directory. Okay? In the demo directory, they do have a lot of different source examples of how to do different things. So, I'm not going to go through every single one of them, but they're in here, and they explain or give little demos of little portions of libraries that actually are given out with FreePascal that are included, and they give you just enough of the demo so that you can kind of see it work. All right, there's other places to get more information, both online and from the documentation that comes with it, which we're going to go through. So here's your basic demos that come with the system. All right, specific ones for Win32, for example, testing DLLs, because you can hook with DLLs. It can be a little tricky, but you can definitely. There's nothing stopping you from using Windows DLLs. Generally, the hardest thing is if you have a DLL and someone gives you a C or C++ header to talk to that DLL, you have to convert that header to FreePascal data types and such, and calls, function calls, so that you can actually call these you can make these external calls, they're called, to these Windows DLLs and such. And the same holds true when you're dealing with Linux shared libraries and such. So those are things to consider. There's a utility that actually comes with FreePascal, and it's one of the files that's inside of the bin folder that we were just looking at. It's called C2Pascal or something like that. It's in here somewhere. Come on, where are you? There is a program that helps you with this. You might have to download it separate on their website if they're not distributing it anymore. H2Pass, header to pass. This is it right here. H2Pass, that converts a C++ or C header to code that's Pascal. But it's not perfect because some of the calls in C and C++ can be kind of complex. This thing does its best to do it for you, but you often have to go back in there. I'd say you should always go back in there and look at what it did. This requires an understanding of the FreePascal data types as well as the C and or C++ data types, so that you have a good understanding of what's being done. So you can look at what the C header is trying to do and then see what code was generated for Pascal and maybe make changes to make that work and do some testing to get all that working. There are groups of people, for example, that do this on their own time for free. One of them is the Jedi group. They have libraries and stuff that are already for FreePascal that'll work with OpenGL, which is a graphics library, an open source one in fact, as well as working with DirectX, which is a graphics library that is a Microsoft product. And both of them are excellent products. Some people totally love DirectX. It does have a crisp look to it. Then there's OpenGL, which you have the ability to go from platform to platform, and it still looks good. It just doesn't maybe have some of the crispness. But I think that's changing too, because it's constantly being advanced too. So it's nice to know that you have both options available to you. Even though I mean, you're using FreePascal, it doesn't seem like the normal way to go with those particular engines, but FreePascal is more than capable of doing it. All right, so going back to the, we just did demos. We just touched on a utility and bin. In the document folder, there are manuals, PDF files, and there's various ones. All right, very important. I don't know what each one of these does, but I do know quite a few of them. The FreePascal documentation, pretty much, let's just take a look at it, because I know there's the programming, there's the reference manual, FP docs usage. Let's see. Description file, generated output files. Okay, I think this is actually for making documentation of FreePascal if you are a developer. So we're going to skip that one. Because FreePascal is open source, not only is it a programming language that they're telling you how to use the programming language, it's also a project, an actual project in and of itself that gets developed and can be compiled, and you can add documentation to it yourself. You can actually contribute and be part of the team or the global effort to support and maintain this programming language. Then there's the actual programming reference manual. All right, this has all kinds of things: compiler directives, local directives, using conditional messages and macros, using assembly language in line. So if anyone you got some hardcore assemblers out there, assembler programmers who like to do machine code because they know how to get the raw speed out of a CPU, there's information about that, including for the Motorola. Generated code, units, programs, the Intel MMX support, which are specific machine language extensions that change the mode of the CPU so that it's in a state that's actually more conducive to doing very fast operations with hardware. That is for video. Okay, so we have, I mean, there's just a lot in this. The programmer's manual has a lot of stuff. You know, the anatomy of a unit file. These are different things I want to cover. Basics, readings. And I'm going to cover some of these, but nothing can replace the manuals. And I'm a human being, and I'm going to make mistakes, but I'm just trying to see if I can't jumpstart that. The next thing is the programming reference. This kind of goes over, like, just the core of the language, the types, the variables, objects, classes, interfaces, generics. Never been a fan of generics. Some people totally love them. Expressions, statements, using functions and procedures, operator overloading. I'm not a fan of operator overloading either. And the reason is that if you start changing what the definition of a plus sign is, when you're looking at someone's code, it looks like a plus sign. It doesn't make sense. It doesn't make sense, and they might not use plus at all for adding. It might be some weird anything. With operator overloading, it can become very abstract. So that's why I stay away from them. You can accomplish all the same things that you could with operator overloading without it. Programs, units, blocks, exceptions, using assembler. Okay, there's a lot of stuff covered here in the FreePascal reference guide. So remember, that's ref.pdf. All right, then there's the RTL. That's the runtime library. This is the stuff they give you that's extra. These are the hardcore tools for the most part that basically allow you to do a lot of stuff with FreePascal. It's one thing when you have a language. The same thing with C++. If someone gives you C++ and nothing else, you can't really do a whole hell of a lot. People are like, well, why is it powerful? It's kind of like, this is kind of hard to justify. Same thing with FreePascal. I got FreePascal installed. I wrote Hello World and I made a unit. So what? I mean, I can write things on the screen. Now what? These are different units and stuff that are, the same as using, let's say, the Windows API or something like that allow you to stop being able to go out of the box and start being able to interact with things or do neat things. Here's the CRT unit. That's for doing console kind of stuff. There's C threads, reference for doing multi-threading, multitasking. They have various types, various string units. There's a DOS reference, and this DOS reference is not necessarily thinking of old Microsoft DOS, although it started that way. It actually has a lot of different functions, like taking a file name and breaking it out into the drive letter. If there's a drive letter, if you're in Linux, you won't get one. You get the path, and then you actually get the file name, and you get the extension. It does different things like that by parsing and breaking up. It's got utilities like that in there, like reading a directory. It's got all kinds of different tools that have to do with the disk operating system in general, not necessarily the Microsoft DOS or any of the other DOSes that might have been out there that were the thing for a while there. Going back in time a little. There's the graph unit. This is a very basic graph unit. It's basically almost like a bitmap that you can program. Graph unit is, like I said, simplistic, but it actually has a lot of valuable uses. A lot of people will use it because it's kind of lightweight and they can do something quick. Good for doing, let's say, electronics project, and all you need is to show as a sine wave along with a bunch of other data on the screen. That might be the tool for you. That's not like a windowing GUI or anything like that, hardly. I just wanted to point out it's a neat little tool that you can have do graphics on the screen. All right, then there's the heap reference. The reference for IPC, that's inter-process communication. That's when you have two different programs, applications, talking to each other on the same machine. There's a lot of different stuff here in the runtime library, but all this stuff is included. You can see as I scroll, there's quite a lot here. String utilities, system unit, got a bunch of routines you can use. Sysutils has got tons of stuff. I think after a while, you're going to have sysutils included in almost every one of your programs. Reference units for types, type info, reference units specifically for Unix stuff that's just Unix only. And that's kind of what that's for. Reference for the video unit, which is controlling base, still like the console, but it's kind of like the low level of the console. And then you have the WinCRT unit, which I never had to use. I think if I just used their regular CRT unit, I've been pretty good with. I should say I got away with using the console unit. I don't usually mess with the CRT unit specifically, or the WinCRT unit. Then there's a reference unit for x86 too. Alright, so that was just a quick skim of what's in here. And then there's the user manual, which kind of shows you how to do the compiler options, the switches. It may or may not cover, I don't know if it covers the way the configuration file works, but the configuration file really is the same thing as using the compiler switches on the command line that are explained in this user.pdf file. It's basically a collection of those in a text file so that you don't have to type them in all the time, because there's a lot of them. And if you think looking at it that there's a lot of them, if you go into Visual Studio, there's like 5, 10, maybe 20 times as many switches. So if you've ever tried to run Visual Studio's C++, the command line tool, which is what it really is. The Visual Studio is just a skin on the front of it. All those options and things you select on how your program's going to get compiled actually turn into like sometimes like 100 or more command line switches, along with your file name, project name, libraries that are getting it included, all that kind of stuff, and fired. So that's it's the same thing happening here. Different language, same basic stuff. There's a lot of different options, and it's probably useful to get to know what some of those are. And there we are. So that's the basic deal there. Okay, now going back up, we have more examples in the example folder. So we have the demo, and then you have the examples. The examples have a lot more to do with what's in the runtime library. But there's a lot in here. Things for dealing with the CD-ROM, for example. Things else that might be important. Dealing with the GTK library, and there's 2 directories on just that. Doing hashing, doing HTTP D2.0 and then 2.2. It's got iBase stuff, which I would think has to do with like dbase and things like that. I believe. I don't know. You'd have to take a look. They have an XML library. I personally wrote my own. I found it to be a little simpler to use, to be honest with you. This is MySQL. It has information in there to access MySQL 3 and MySQL 4. And you might be like, yeah, but I'm using MySQL 5. Well, the MySQL 4 stuff does work. However, on Linux, you might have to find the right libraries and maybe make a what's called a I'm trying to think of the right word here, a symlink. You might have to make a symlink to the appropriate MySQL library. Also, it's going to be important that you link to the proper library that is for the endian that you are using. Are you using a 32-bit application or 64-bit? See, on Linux, some Linux distros allow you to do both 64 and 32-bit applications on the same distribution or the same installation of Linux, so you need to take that into account. Alright, then you got ODBC, OpenAL, OpenGL, you got stuff for Oracle, you got the PassZlib. This is basically your WinZip, more or less, stuff you can do. I wrote a little program that zips up files and unzips files using it, and I use it for my own installation program. Very neat stuff. I haven't had a chance yet, but I'd love to mess with this Postgres. This is a different database engine, very similar to Oracle in its behavior and in its features, and something to know about. There's also a library for regular expressions, and I'm not sure what this pxlib is, but regardless, there's a lot of examples of code and stuff that comes with the runtime library. Again, these are extras that are given with FreePascal that they're really a bonus. They're you know, icing on the cake. You get the language plus a bunch of tools. All right, so that's neat stuff. So let's see, message folder. I have no idea. The units folder. These are the ones that actually are being used when you're using the runtime library or the stock units. This is just where they are already compiled, ready to be used. So we don't need to worry about this too much. That path is actually probably set in the configuration file that's located in the bin folder, and it's fpc.config. And this is what it looks like, just so you can get an idea what I was talking about when I say the configuration file. Is it's got a whole bunch of switches in it. A lot of them are commented out as examples, but as you see here, this one is not. So I mean, there's certain ones that are turned on by default. Not many. Most of them are commented out, but here's some more too, like the path, where those units were that we were just looking at, for example. This is the search path for the units and other system-dependent things. So a lot of this stuff's already set up for you, and it's in your path. It's going to get used. You don't have to worry about these right away. However, if you wanted to have multiple configurations for different projects, you can copy that fpc.configuration file, move it to your project directory, and then edit your changes. And if your code and everything's in there and you're compiling in that directory, that copy of that copy of the FPC configuration file will be the one that's used when you run it. Okay. So next thing I want to cover is we're going to go back to the temp folder. We're going to make what's called a unit. This is a new kind of program thing, and we're going to do some stuff here. We're just going to call it unit.pass. I actually use the direct. There's two extensions for Pascal source code. That's PAS and PP. To separate my programs from my units, I name them, like for my Pascal programs, I name them .pas. For my units, I use the file extension PP, just to keep them separate. All right. And here's the basic use of a unit. Let's see. Open with my JGS edit. Okay. You want to use the same name. I wonder if that's going to work because it's unit. I know it might not. Hopefully it does. Because it's a keyword, it might not work. Alright, so in fact, let me just test that by going like this. Begin, and with a period, and I'm going to just save that, and we're going to go to the command prompt and see if it works, because it might not. FPC unit. It didn't like that, I don't think. Oh, it might. Let me try one more thing. There's interface and there's implementation. Those are two spots, and I'll explain that. It's kind of like if you're doing a DLL, right? These are in fact libraries. They're not separate files when they're compiled, though. Well, I guess they are, but they're when they're compiled, it's all part of your program executable. It's not like it ends up as being a list of DLLs and your program calls the DLLs. Basically, when you compile it, you have all these intermediate files, and when it links your final program, they all get linked together. All right, so interface basically is what you're going to share, what you're going to expose to the program that's using it, or to the other unit that's using it. Then in the implementation area, that's actually where your code's going. And down here, this little begin end, this is that little spot I told you about where you can have an initialization code if you want to have for your unit. If you get rid of the begin, that's valid. That just means that, you know, you're going to have your functions here, you know, test, you know, boolean, and oops, I got to spell it right. Function, test, boolean, begin, or I don't know, we can say, I guess, test equals true. I don't really like this method, though. I'll tell you what I do in a minute. We'll get to that. I'll show you. We'll talk about that. Mode objects C allows you to use the word result as opposed to the function name for the result. But anyway, this would be basically fine. You'd have your implementation code here, and then your end would just mean that's the end of the unit. All right. If you want to have that initialization code, that's when you would have the begin in the end, like that. Okay. So that's the basic construct of a unit. But we're gonna have to pick a different name for this. So we're gonna call this unit test, because it needs to not be, I don't think it can be a keyword based on what I saw. So, let's go to our program, temp pass, open with, Jake said it, and we're going to tell it that the program uses unit test. Done. If you had multiple units, you would use commas and then have other names and commas and other names. Sometimes when that list gets kind of big, it goes too far to the right, so I do something along the lines of this. I actually will do something like this, and I just keep putting commas in the front. So every time I add one, I just have to do the comma in the front and go like this, whatever the unit name is, blah, 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 blah. And then I put my semicolon at the bottom. That's just me. That's how I would include a bunch of units. But we're only including the one, so I'm just going to go ahead and do the one-liner with a semicolon at the end. Okay, and that's that. So let's see how we're doing. Okay, illegal unit name, unit test. And the reason for that it's illegal is because the name is wrong on the actual file. So we're going to rename the file to say unit test as well. This needs to match. Same with programs, unit test. Okay, so we have unit test. So let's go back and see if we can compile now. All right, it says can't open file unit. What did I do now? Let's see. Open with. We already got this open. Unit test. Okay. Well, this is good that we're having an issue. Do I feel silly? No. This is the kind of stuff I fight with everyday programming. Don't care. Unit test. Function test. Test equals true. I'm going to kill this function right here. Unit test. That should work, man. What's up? Illegal unit name. Unit PP. It's still trying to compile unit PP. Didn't we rename that thing? Oh. That should help. I don't understand what the deal is there. Cannot open file unit. Where do I have unit? Did I not save this? Cannot find file unit. Oh. Hello. I was editing the wrong file. It was still in memory or something. Still saying the same thing. Gee whiz. I'm going to open up a file in another directory just to see what I am possibly doing wrong, which I don't think is anything, but whatever. We'll look at one of my units. They get a little big, so don't be daunted. I wasn't going to start by I'll start with a simple one. Unit. This is an easy one. At the very end, I have my begin and end. At the very top, it says unit. I have my interface part here. I should have my implementation part. Yeah, I do. There's nothing behind it. Maybe it's because I got that junk in between the interface. I have nothing between my interface and I know I should know this, right? Master's trying to show you, but that's okay. Interface. We'll say something like this. We're going to have a variable called unit variable. We're just going to call it string, and then in implementation we're going to put a function that is a boolean test boolean and begin and b test equals true, and some luck please here. This is simple stuff. I should be able to do this. Fatal, can't find this. What? Oh, it's saying FBC unit. Duh. I don't believe you. No one helped me. Thanks for helping me, people. I was compiling the wrong file name. FBC temp. There. Totally compiled. Alright? It was because I was trying to compile the old unit name that we did delete. I created a new unit name and it didn't work because I was compiling this file that didn't exist. So we're good now. Alright. Back on track. Alright, so I want to point out something on the program side first of all. With Pascal, you really, the way your program starts, this begin and end thing, this actually happens at the end of your program. Right? It doesn't happen first. And in order for it to know what routines you might be calling that are in your program, they need to be above it. And if they call other routines that's in it, they need to be above it. So you actually have to build your program kind of stacking upwards. It's like, seems backwards, right? Well, that's kind of how you have to do it. Now, in units, there's that interface spot which makes it a little easier. So I personally keep my my programs kind of shallow. I don't make them too big, so I don't have too much of that. I don't have to worry about it. So I don't have to stack, and then I'm like, oh, well, I need that one down there now, and I get all that. So I solve that just by doing most of my coding in the unit side. And then you're like, okay, well, what do you mean by that? All right, well, I mean this. In the unit side, I have this function test. All right. So on interface, what I do is we have this unit var. That's something I'm making available to my program that's using this unit. Right? So that's a variable. The other thing I can do is make the function that I just wrote down there called function vtest. I can make that available to the outside program. So I go like this. I declare it here. Function vtest boolean. Okay? Now, if I compile this unit, or this program, I can actually go to the program side and say, I can make it call that function btest, and it'll work because I have it in the interface. That's the part on the top. Now, on the implementation side, I can have a ton of functions like this, and I'm going to call them just btest1, 2, 3 to get the point across. All right. 2. I can, in any one of these functions, all right, right now, they have to be in the same order like when I'm programming, because I haven't done anything except for the one at the top, btest. So in other words, btest2 can call btest1 because it's lower. And to make it clear as to why it's this way, FreePascal compiles fast as heck. And it does that by compiling one pass down. So as it's going down the file and compiling, it's learning what's available. So until it gets to the spot where a routine is that you need, so it knows it exists, you can't call it. So that explains why right now btest2 can call btest1, btest1 cannot call btest2, and btest cannot call btest1 or btest2. However, if I went like this and put them up here in the declaration and defined them, now the compiler reads those first, knows that they're there. Now it doesn't care what order stuff is because it already knows that where the files are, or where, I'm sorry, the routines are available, where they are. They're already defined. They're already declared. Now you'd be like, well, I don't want btest2 and btest3 to be available to the outside. I was going to use them just inside my unit. I wanted to keep those private. So instead of putting them up in the area here that's interface, okay, we want to put them down in implementation. If I wanted to keep these two only declared inside of the unit so the outside program doesn't have the ability to call them. Also, let's say you have a variable name or something that only the unit uses, and that variable name is the same in another unit. This is a way of hiding those two same variable names from each other. Okay? So that's the basic architecture of how a unit is put together. Functions return values, and of course there's also procedures, which I didn't cover, but procedures are like functions except they don't return anything. So what can you do if you wanted to really pass some information back? Well, you could use something called by reference variable. And what that does is, as opposed to passing a variable as a parameter in, test proc, instead of passing a variable in just like this, a string that's coming in, for example, okay, you can actually do something like this where you put VAR in front of it. And what that's doing is, if you do something down here and say PV equals hello, alright, the original variable that you called this function with is actually going to get changed. So if you said in your program test proc my first name as your variable, when it gets in here, when it's done, your my first name variable is going to be equal to hello, because it actually changes the original variable that was passed, because it's by reference, and you do that with the VAR in front of it. Okay, so that's basically the difference between a procedure and a function, and how to pass by reference, which is the difference than the standard, which is by value, which is done on the stack. And long story, but long story short, the VAR makes it so that if you actually change the variable inside the procedure, it changes the one outside that you called with. Okay, so there's that. There's also something here we were getting down here with btest equals true. I don't like this nomenclature where the function name is btest and then I have to do btest equals true to return a result. I like to return a result that has the word result. So there's a thing you can do right underneath unit. There's various compiler directives that you can turn on and off that are available in the documentation. And one of them is the one I like, is object mod. It might be mod object. I think it's mod object. Mod obj. It basically turns on, I think I got that right, mod object. Let me look at my other directory here to make sure I got it right, because I use it all the time. Mode object FPC, that's what I want. That was close. Alright, mode obj FPC. Now I can do this in my function. Now I can say result equals true, and to me this is more intuitive. This is it turns on a Delphi, some Delphi features, and I like that. So that's just me. So there's an example. I've walked you through the steps of, and at least if it's hard for you to follow because I'm kind of going fast, it's because I'm trying to cover a lot of ground, but at least you got some of the nomenclature or words that you can use to either Google or look in the documentation and search for to kind of figure out what I was talking about, so you can start applying this and trying this stuff out yourself. So we've worked on a unit. We've covered up the basics of how a unit's put together. We covered why we build from the bottom up when we're doing this, is because the compiler goes down and what it sees first it knows about, so it knows it's available as it goes down further if a routine calls something that's already passed. If you try to call something up here for something down here and the compiler hasn't gotten there yet, it doesn't work. Alright? If you want to define stuff, you can define it below the implementation area, keep it private in your unit, or if you want it to be public to programs that might include that unit or other units that might include that unit, you would put them underneath the interface. And last, at the very end of the unit, if you wanted to have initialization code or call some functions and stuff, you can do that down here. That will get fired up when the program starts. Every unit's initialization code will be fired when the program starts, and you do not necessarily have the control of the order of that firing. I believe it goes, if you have the stack of units, it does the last one first. But if you have multiple units in your one program, you got multiple units and they're calling multiple units, it gets pretty hard to discern which one's coming first. So I'd be very careful about writing the code in the initialization routine so that it only affects the unit, and that it only affects the unit in such a way that doesn't impact other units. So just keep that in mind. That's the recommendation. Okay, so let's see. No. All right. And just out of the box, some of the stuff that you can do with FreePascal, just using like the CRT unit without using, there's another product or a project called Lazarus FreePascal, which uses has like a GUI system, which allows you to have a graphical user interface like you would see with using .NET products or VB6 products, or it basically uses the GDK when it's on Windows, I believe is what it does. But basically it writes the code in such a way that regardless of what operating system it's on, it tries to link to the appropriate graphical user interface for that particular operating system. So you can write your program once and compile it on each one of these platforms, and it'll work successfully. And just to give you something cute to look at that I did, hopefully this runs. I didn't do like a rehearsal here, but let's see if I can find a little icon to give me that command prompt deal. This is a little thing I put together that kind of is interesting because it's just FreePascal only, and it's kind of cute and looks neat. So I'm going to see if I can get it to work for you. Helps if I find the file. Hang on. So here's a good way to end our little demonstration here of some of the stuff you can do with FreePascal. Granted, something like this is not going to make you millions of dollars or anything, but it's definitely cute and definitely shows you some of the stuff that comes right out of the box with FreePascal you can use using just the CRT unit and console. If I type it right. Pretty neat, huh? I like the fishies. We got a jellyfish coming on the upper top right. I think you get the point. Oh, we got the shark coming. Watch out. Dun 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 dun. Yeah, I make jokes, but this actually is using virtual consoles. It actually is pretty complicated what this is actually doing. It actually has separate invisible windows that are being populated with pixels and characters and colors, I should say, colors and pixels, to show data where I want it to show. It's clear where it's not. This is actually the same core unit. The structures that I built here, I was able to make a complete Windows GUI, or I should say a console GUI, for working with applications that need to run on Linux, for example, where a GUI might not be available, and that can equally work just as well in the DOS environment in this kind of console window here, as well as work on other Unix systems and Macintosh. So it comes in handy for making interfaces that are pretty much very portable, when sometimes you find that those GUI things just always aren't. If you don't, unless you want to write, unless you're doing very well with Lazarus, or you are actually just writing like different code for each of those platforms, which is what you don't want to do if you can help it. So here's everything together, and that's going to wrap up our example of FreePascal, our FreePascal 102 video. And I hope you've enjoyed it. And my name is Jason Sage with Jagus LLC, and I hope that you have a great day. Thank you.